So last time we have seen, like, if we have two bodies, let's say there is a ground which is not moving, and let's say there is a body of mass mkg which is moving with, let's say, force or with acceleration of, let's say, a equal to or a meter per second square. Acceleration a meter per second square. Then since F equal to ma, force of ma is being applied on this body. So then the friction will basically oppose the relative motion between two objects. So friction force will act opposite to the applied force, and its magnitude will depend upon, it will, first of all, it is frictional force is directly proportional to normal reaction, and we know that it is given as mu n, where mu is coefficient of friction and n is normal reaction. Okay. So we have seen some example last time. So now we'll see, like, calculation of normal and limiting friction. Okay, so we have seen what is limiting friction last time. So so here the mu n is basically the limiting friction, and like if the applied force F is greater than Fr, greater than equal to uh, Fr, or limit, let's say we will write this as limiting friction L, okay, Fl. If applied force F is greater than or equal to limiting force Fl, then friction is, in frictional force in that case will be equal to limiting friction, let's say Fl, which is equal to mu n. And if applied force F is less than equal to limiting friction uh, Fl, then in that case frictional force Fr will be equal to F. And okay, so that thing we have seen last time. So I will just see few example of finding limiting friction and uh, normal reaction. Okay, so again, let's see, we have, if this is a ground or some object over which we have kept one other object of mass mkg, then there will be, let's say, the coefficient of friction between these two objects is, let's say, it is given as mu, or let's say 0.5, and mass, let's say, it is equal to 10 kg. Okay, so in that case there will be weight acting downwards. If g is 10 meter per second square, then weight will be mg, and which is equal to, m is 10, g is 10, so it will be equal to 100 newton, and therefore there will be normal reaction of 100 newton acting upwards. And in this case the limiting friction Fl will be mu n, so it is equal to 0.5 into 100 newton, so it will be, limiting frictional force will be 50 newton. So now if this is not moving, okay, it is at ground. Now if we apply some force F, so until F is less than Fl, until this point, frictional force is basically equal to F, or F is less than equal to Fl, Fr is equal to Fl. And when uh, F applied force is greater than the limiting friction, then in that case, this frictional force Fr will remain constant and it will be equal to limiting friction. So we have seen one graph last time. Okay, so here let's say it is applied force, sorry, it is frictional force Fr versus applied force. So let's say this point is limiting friction Fl. So until Fl, uh, means F and Fr will be equal, and when you cross, when F, sorry, this is till, this is the point where Fl is greater than or equal to F. Okay, and then it will remain, frictional force will remain constant when mm, Fl is less than F. So we have seen this graph also last time. Okay, so can you find out? I will just give one small, very easy question. Okay, let's say there is a one object of mass 20 kg and it is placed over a ground. The coefficient of friction is given as 0.3. So can you find out normal reaction and limiting friction value in this case? And acceleration due to gravity g is 10 meter per second square. So it will just take 10 seconds, I think, to solve this. Please try to solve and type the answer in chat box. Okay, n is 60, n is normal reaction. Okay, n is normal reaction, fl is limiting frictional force. Okay, limiting. Uh, okay, one second. Actually, n is normal reaction. Okay, so 1 second. So here in this case,
Sir,
yeah,
for normal reaction, if there is no force applied, can we should take n is equal to mg, or
yeah,
we should
and
take n is equal to mu
yeah,
mg?
yeah, n is equal to always mg. No, you forgot about friction
Okay,
for
okay,
now.
okay, okay.
Just you
Yeah,
calculate
right.
normally.
Okay.
Yeah,
Then
so it's
mg is 200 newtons, sir. Correct.
yeah,
I'm
it is
sorry.
200 mg. It is 200 and FL is mu n. So it is 0.3 into 200. That is 60. It is correct.
But sir, if force is applied, then we should apply this mu, sir.
Okay, so no, see, for mu is applied only for friction. Okay, mu is not there for normal reaction. So let's say, okay, for example, now you have one object of 10 kg. Okay, and acceleration due to gravity is 10 meter per second square. Let's say you have applied force of 10 Newton from top, and we know that n is normal reaction which is acting upward. Here mg is also acting downward. So if you balance the forces, it will be mg plus 10. Okay, n will be equal to 10 into 10. M is 10, g is 10. 10 into 10, this is 110 Newton. Similarly, if there is again 10 kg mass and it is on ground and there is force of 10 Newton acting upwards. Okay, so in this case mg is acting downwards and normal reaction is acting upward. So here in this case n plus 10 will be equal to mg. So in this case n will be equal to 100 minus 10, that is 90 Newton. So normal reaction, you miss, don't worry about friction when you are calculating normal reaction. Okay, it is not related. But after you calculate normal reaction, then the frictional force, whatever friction limiting frictional force is there, that is equal to mu n. So then mu will come. So mu will come only when there is you calculating frictional force and not the normal reaction. Okay.
Okay, sir.
Okay. Okay. So similarly, if till now we have seen horizontal examples. Okay. So let's say if we have a wall and if we have applied a force F, there is an object of mass M. And so in this case, like just find out normal reaction and limiting friction. So this applied force is F. There is mass M, so weight will always act in downward direction. So which is acting downwards is mg, and applied force is only F. So normal reaction will be also equal to F only. Okay, and limiting friction will be equal to mu times N. So let's say if mu is coefficient of friction, then it will be equal to mu F. Is it clear? Like for vertical, we have just calculated normal reaction and limiting friction force in this case. Okay, we have not done any other things. So is it clear?
Sir, if the weight, gravity is acting downwards, then and if we are pressing the block towards the wall, so
Yes.
the friction is applied upwards, right?
Yeah, friction will be applied upward. Okay, yes, correct.
Okay.
Friction will be applied upward. Yes. So okay, so let's say you have a wall and there is a mass of, let's say, weight, a mass of like object of mass 10 kg. You have applied some 100 Newton force. Okay, so how much should be the, or let's say you have applied 1000 Newton force. Okay, so can you calculate how much should be the mu is coefficient of friction? So what is the value of mu? Mu, that is coefficient of friction. This object won't fall. Is it possible for you to calculate this? Like value of mu for which the object will not fall.
Sir, if mu is equal to, can we take mg, because mu minus mg is equal to 0 according to the free body diagram, which we, if we observe a free body diagram, so
Okay.
mu is equal to mg. So 10 into 10, 100 k, yeah, 100.
Okay. So here we have to find the value of mu. Okay. What is coefficient, value of coefficient of friction for which it won't fall? So I think you are going in correct direction, but is it possible for you to give 2 minutes and solve this?
Let me try, sir.
Okay.
Just give me 2 minutes.
Okay. Okay. Try.
No, sir, I'm not getting properly. Can you
Okay.
explain how it is done, sir?
Okay. So this is the wall. Okay. This is the wall, and you are holding this object with the force 1000 Newton. Okay. So now our aim is like we have to find out what should be the coefficient of friction so that this object will not fall down. So there is weight of this object acting downwards. Okay. Let's say if g is 10 meter per second square, weight of this object acting downwards is 100 Newton. So if 100 Newton is acting downwards, then frictional force should be greater than 100. Okay, it will act in upward direction frictional force. So if frictional force is greater than 100 Newton is acting in upward direction, then only uh, this object will not fall. Or if limiting friction is basically if it is greater than 100 Newton, then only this object or greater than or equal to 100 Newton, then only it will not fall down. Okay. So what? So if 1000 Newton is you are applying, normal reaction will be equal to, it will also equal to 1000 Newton. Okay. Here
Okay,
we
sir,
don't.
got it.
Okay. Okay. So you know that normal reaction 1000 Newton and FL, that is limiting frictional force, should be greater than 100 Newton or greater than equal to. So if you know that formula of FL is mu n. Okay. So mu n is should be, this should be greater than 100 Newton. Okay. So mu is unknown, n is 1000, should be, this should be greater than equal to 1000. So mu should be greater than or equal to 0.1. Okay. Is it clear?
Okay, sir.
Okay. Okay. Is it possible for you to find out the limiting frictional force FL and normal reaction in this case? Can you try?
Yes, sir. Let me try it once.
Okay. Take,
Sir, one small clarification. If I'm taking as n is equal to mg sine theta, is it correct?
you are taking n equal to mg sin theta. Okay. Yeah, it is correct.
Okay, sir. Sir, FL I'm not able to find. Limiting friction I'm not able to find.
Okay. So, okay, I forgot. You know that mu is coefficient of friction, right? You know, right? You can always take mu as
Yes, sir.
coefficient of friction. Okay. Okay. So here, first I will just try to show you. Let's you this mg is acting downwards. Okay, force, that is weight of this object. Okay. So if you draw this triangle, now see this and this. Okay, once again, this and this are perpendicular. Okay, this and this surface. Uh, hmm. So the angle of wedge is given as theta. So this angle is, if this is 90, this angle is 90 minus theta. So if this angle is 90 minus theta, and again since this is 90, this total angle, so this angle also become equal to theta. So now if you draw the component of this mg along this direction and along this direction, then this direction will become mg cos, sorry, I think I told you it was mg, no, it is mg cos theta. Okay. This the
Okay, okay. Got it, sir.
the okay, the normal reaction is equal to mg cos theta. And the second is limiting frictional force. So mm, limiting frictional force is just mu n. So mu n should be equal to mu mg cos theta. Got it?
Yes, sir.
Yeah, so it is equal to mu mg cos theta, limiting frictional force. So I will give you one example based on this.
Sir, in that question, n is equal to mg sin theta only should come, no, sir. Cos theta is, if I imagine this properly, like a right angle triangle,
Yeah,
then that n is equal to mg sin theta only it will come, no, sir.
no. Just 1 second, okay. See, if you consider, mm, 1 second. Okay, once I will draw. So this angle is theta, okay. Now, if you draw here some dotted line I'm drawing, okay. So this is right angle triangle, okay. If this is a right angle triangle, this angle is 90 degree, you can clearly see. So this angle will, other angle is theta, so this angle will become 90 minus theta. Is it clear till this point?
Yes, sir.
In this right angle triangle, theta 90 minus theta and 90 degree, these angles are clear.
Mm, yes, sir.
Okay. So now the weight is acting vertically down in vertically downward direction. Okay. Till now it is clear.
Yes, sir.
Now see, this is the surface. Okay. This is our surface. And so normal is basically perpendicular, right? Normal is
Yes, sir.
perpendicular. So if you take component of uh, this mg along this point, so this angle is 90 degree, correct? This angle
Yes, sir.
as well as this angle, both are 90 degree. Are you agree? Do you agree?
Yes, sir.
These both angle are 90. Okay. So now if
Yes,
you
sir.
see, if this total angle is 90 and this small angle is 90 minus theta. So total angle is 90. We have to find, let's say this angle is x. Okay. So 90 is basically x plus 90 minus theta. Till now it is clear.
Yes, sir.
So 90 will get cancelled. So x will be equal to theta. So this angle x, this is basically equal to theta. Okay.
Okay, sir.
So now you have force mg acting downwards. And you have to find its component along this axis. Okay. This component you have to find, right?
Yes, sir.
1 second, I will draw bigger. Hmm. This is, let's say, vector. We have force, right? This is vector mg. Okay. And mm, this angle is theta. So if you draw a right angle triangle now, okay, this length is mg. Okay, this length is mg. This length, let's say this is x, this is y. Okay. So what is cos theta here? Can you tell?
Uh, mg by, sorry, wait. Yeah,
See, this is 90.
adjacent side by hypotenuse.
Ah, so which is adjacent side to the theta, angle theta?
Mg.
Ah, see, this is 90 degree angle. This angle is 90 degree. Okay.
Oh, okay, sir. Wait, just 1 minute, sir. The diagram is little bit weird, no, sir. That's why I'm not able to identify properly.
One second, I will draw one more diagram.
Yes, sir.
Well, and one thing first I will like to tell you, like if you have some force, let's say F, okay, then
Yes, sir.
let's if this is X direction, this is Y direction, then its component along X axis is basically its projection on X axis. Okay, got it?
Yes, sir.
And its component along Y axis is its projection along Y axis. So these component can never be bigger than the actual force or actual vector you have. Okay. So if you are drawing this as fx as x component, fy as a y component, then fx and fy will not have bigger magnitude than actual force. It can have equal magnitude. If it is in x direction, fx will be equal to f. If it is in y direction, fy equal to f. But they won't have bigger magnitude than actual force f. Okay, because those are the components of actual force. Okay, is it clear?
Yes, sir.
Okay. Similarly, your actual force here is mg. Okay, let's say this is mg, and you are finding its component along some direction. Okay, so there is one component, let's say this is, so let's say this was your mass m. Okay, this angle is theta, that is clear to you, right?
Yes, sir. That's clear.
Yeah, that's clear. So this is the component of along the wedge. This is the component along the wedge, and this is the component normal to the wedge, right? Which we have to find out normal.
Yes, sir.
So now these two are perpendicular to each other, right? It is clear, like these, and this. These are perpendicular to each other, right? These two components.
Yes, sir.
So now we have seen the law of vector where you can move this vector here directly like this. And
Yeah, correct, sir.
okay, its magnitude and direction will remain same. Okay. So now this angle is 90, right?
Yes, sir.
Yeah. So this angle is 90. This angle is theta. So
So the adjacent side is.
let's say this is adjacent side x. If this is this is angle theta, this is adjacent
Yes,
side
sir.
x, and let's say this is opposite side y. Y is opposite to theta, right? And x is adjacent to theta. And since mg is the main force, it is the bigger one, and it should be the hypotenuse. Is it clear?
Yes, sir. It's clear.
So now cos theta will be equal to x upon mg. Sin theta will be equal to y upon mg. So x is basically mg cos theta, and y is basically mg sin theta. So if you have a mg mass, like weight acting downward direction, then this is mg sin theta, this is mg cos theta, and this angle is theta. Is it clear?
Okay, sir. Okay.
Okay. So I will just give you one problem to solve. You just calculate the normal force and limiting friction. Okay.
Yes, sir.
mu is given as 0.3. So find out normal force and limiting frictional force.
Yes, sir. Just give me 2 minutes. I'll just solve it.
Okay.
Sir, the mass is 25 or 20?
20 kg, 20,
20. Okay.
20 kg, yes.
Sir, n is equal to 100. I'll calculate and say you the limiting friction.
Okay. N is equal to 100. Okay.
Sir, limiting friction is 30.
Yeah, correct. So here 20 kg is there. So of course 200 Newton will act downward, and this will be 200 cos 60. So cos 60 is 1 by 2. So 200 into 1 by 2. So and this weight acting in this direction is basically 100 Newton. So it is equal to normal reaction, and FL is basically mu n. So it is 0.3 into 100, that is 30 Newton. Okay. Now let's see, we have one object, uh, and there is one more object of mass m kg, which is like just in front of the first object, and it is moving, both are moving with, let's say, acceleration a meter per second square, and coefficient of friction is mu between them. So if we have to find out normal reaction between these two objects and limiting friction between these two objects, then what will we do is we will apply the concept of pseudo force. Okay. So when pseudo force is, we apply pseudo force, basically we consider this is not moving, and there is a force of, if you consider this object, let's say this m kg. So when we apply pseudo force, basically we will apply force of magnitude equal to mass of this object into the acceleration, okay, in opposite direction. So in this case, normal reaction will be equal to ma, where m is mass of this object and acceleration of total system. So this will be the normal reaction, and limiting friction will be equal to mu n. So it will be mu ma. Is it clear?
Yes, sir.
Okay. So now let's say mu is equal to 0.1, and mass of this object is let's say 10 kg, and A is equal to 5 meter per second square, that is the acceleration. So find out normal reaction and limiting frictional force. So in this case, if we apply the if you consider this 10 kg mass, so if we apply pseudo force concept here, so it will be M is 10, A is 5, so it will be 50 Newton acting in this direction. Let's say normal reaction is N, so it will become equal to 50 Newton. And limiting friction is mu N, so it is 0.1 into 50, and that is equal to 5 Newton. This question they can they can ask it like simply ask this question, and they can add some extra masala to it. So let's say you have two objects. This one is having mass m1, this one is having mass m2. Mu is coefficient of friction between them, and F is the applied force on this object. So now find out friction, normal reaction and limiting friction in this case. Okay. So what we generally need is to find out normal reaction and limiting friction is the pseudo force. Okay. Or basically pseudo force is m1 into a in this case. So first we will have to find out the acceleration. So acceleration of this system will be equal to, since F is equal given as ma, here system will consider m as mass of system. So it will be m1 plus m2 into a. So acceleration in this case is basically F upon m1 plus m2. Okay. So therefore, now if you consider this mass m1 and you apply pseudo force, then it will be equal to m1 into F divided by m1 plus m2, because it is equal to ma. And therefore the normal reaction, this is the normal reaction n. So normal reaction will be equal to m1 into F upon m1 plus m2. And if we got normal reaction, limiting friction can be found out using F equal to Fl equal to mu n. So it will be mu F, m1 F divided by m1 plus m2. Is it clear?
Yes, sir. Just let me go through this, sir. Please don't move the slides.
Okay.
Yes, sir. Understood.
Okay. So we'll take one example. So let's say you have two masses. One is having mass 10 kg, other is also having mass 10 kg. Okay. And coefficient of friction between them is 0.2, and applied force is, let's say, 10 Newton. So in this case, how we have to find out frictional force, like limiting frictional force and normal reaction, okay, between two objects. So of course, whenever we have to find out normal reaction, we'll take this object of 10 kg, this object, and we'll apply pseudo force of m, that is equal to 10 into acceleration. Okay, so it will be 10 into acceleration, and it will be equal to the normal reaction. So normal reaction in this case will be equal to 10 into acceleration. And acceleration we know we can find out using force upon m1 plus m2. So in this case, it will force is given as 10 Newton, and m1 and m2 both are 10 kg. So 10 plus 10, 20. So acceleration basically you will get it as 0.5 meter per second square. So normal reaction will be 10 into 0.5, that is equal to 5 Newton. And limiting frictional force is Fl, that is mu n. So it will be equal to 0.2 into 5, and it will be equal to 1 Newton. Okay.
Yes.
Can you find out normal reaction and limiting friction in this case?
1 minute, sir. Let me go through this question.
Okay, okay.
No, sir. Can you solve this one for me?
Okay. So have you understood the previous one?
Yes, sir. Previous one I understood.
So it is a similar one, right?
Sir, but since the force is acting this side, the 1 minute, sir. Let me solve this and I'll say the answer.
Okay.
Sir, n is equal to 4. I'm getting 4. N is equal to 4.
Okay. See, so first of all, you will have to find out the acceleration of the system. So acceleration is force upon mass of the system. So force is given here as 200 Newton. Mass is basically m1 plus m2, so it is 40 plus 10. So acceleration will be equal to 200 upon 40 plus 10 is 50. So it will become 4 meter per second square is the acceleration. Now you apply the concept. So it is whole system is moving with acceleration 4 meter per second square. So now if you apply the concept of pseudo force, let's say this. So pseudo force is basically, so this object is, let's say, moving with 10 Newton per meter square. So how much is the force we need to apply to stop it? So let's say it is, this is 10 kg. So m into, so it is having acceleration a, so you will have to apply force of ma on it. So it will become m is 10 into 4. So this much will be the normal reaction provided. So this, it will be equal to 40 Newton. Okay. And limiting friction is mu n. So it is equal to 0.1 into 40 there, so it is equal to 4 Newton. Okay.
Okay.
Acceleration is 4. Similarly, they can ask you a question like, okay, so let's say this is moving with acceleration a, and there is a mass of m kg placed over it. So how much is the frictional force? Basically, limiting frictional force and normal reaction on this. So basically, if you consider this mass m kg, and if we apply the concept of pseudo force, so force of ma will act in opposite direction. So normal reaction is only provided by the weight of this object. Okay. So if n is the normal reaction, and so it is equal to mg in this case. Let's say mass is mg, and limiting frictional force is basically depend on normal reaction force. So it is of course mu n every time. So it will be equal to mu mg. Got it?
Sir,
Do you
then
have,
where friction will act, sir?
see, friction will act here. See, if this is the object, ground object is there. So I- if this is top one is basically not, bottom one is moving, and because of bottom one is moving, top one is also moving. So on, if you see the frictional force, so frictional force will act on this topmost portion on in this direction, because, and it will act on the bottom part in opposite direction. Okay, because it will try
Okay,
to
sir.
stop the relative motion between two masses, and since the bottom one is moving in the rightward direction with acceleration a, there will be force in opposite direction that will act on it, and since bottom part is moving at highest, let's say some acceleration, the top one will try to miss, because it will try to stop its relative motion. uh, the force will act in opposite direction on it.
Okay, sir. So for upper block, friction is on forward direction, and for the block below it, the friction is opposite direction.
Yes, because see, if this object is not moving, okay, and so relative to this, so it is frictional force is relative force. Okay, so relative to this bottom box, upward box will try to move in this direction, right? Because this is having some acceleration a in the rightward direction. So relative to this upward block will try to move in this direction, uh, uh, opposite direction to this. So therefore, frictional force is opposite to the direction of this block. So therefore, frictional force will act in this direction, and it will basically help both block to move together. Basically, in this case, okay, means it will, uh, if the relative motion is like, if you consider the relative motion, if let's say this is block A, this is block B. So if block A is moving in this direction, block B is moving in opposite direction. So since frictional force is trying to oppose the relative motion, it will act in this direction, and it will try to push block B in the direction of block A. Okay.
Yes, sir.
Can you find out normal reaction and frictional force in this case on this block basically? Okay.
Yes, sir. Give me 2 minutes.
Okay.
Sir, can you once just show how to solve this one so that I get an idea how to solve it?
Okay. Okay. So I just asked to calculate normal reaction and the force. So you know that mm, in this case, even if you consider pseudo force will act in this direction only. Let's say it is MA, so it is 20 into 10, so it will be 200 Newton. Okay, so pseudo force won't play any role in normal reaction. So if you have a mass of 20 kg, normal reaction, since weight will act downward 200 Newton, normal reaction will be equal to weight and it will be 200 Newton only. And frictional force, limiting frictional force is basically mu n, so it will be zero point 0.3 into 200 and it will be 60 Newton. You just have to see whether any force is acting in the direction of normal reaction, and if it is not, the normal reaction is equal to weight of the body, and like that you should calculate. And this acceleration and velocity, you should able to correlate all our previous concept like motion in with constant acceleration and all other things. So is it and like have you understood or still you have any question?
Force was acting effectively. Sir, one more. Can I join the 15 minutes later? Sir?
Your, your voice, your voice, your voice is not clear. Hello. Can you type?
Sir,
Can you type? I'm not able to hear you properly. Okay, okay, fine. Okay, then we'll meet around 6:35. We'll start around 6:35. Okay. So we'll see one question now, like previous year question. A block of mass m
I'm not able to hear you.
Can you hear me now? Hello? Now? Now can you hear me? Hello? Hello? Okay, can you hear me now?
Hi, sir. Now I can hear you.
Okay, fine. Okay. So we'll see one previous year question now. So a block of mass m is in contact with cart C. Okay, as shown in figure. The coefficient of static friction between block and cart is mu. The coefficient of static friction between block and cart is mu. The acceleration alpha of the cart that will, so find out the okay, they have given the alpha. Okay, the acceleration alpha of the cart that will prevent block from falling satisfies. Okay, so the acceleration alpha of the cart that will prevent block from falling satisfies. So first of all, they have given one diagram. So
1 minute. Something error is happening in my device. I'll just rejoin.
okay, fine. Okay, are you there?
Sorry, sir, for my inconvenience, sir. That my earphones was giving me some error to my device. So whatever I was able to hear, I could not hear what you said. Can you just repeat it?
Miss, now everything is correct, right? Now everything is fine, right?
Yes, sir.
Okay, okay. So we are solving one previous question. So that is a block of mass m. So this is the block of mass m. It is in contact with cart C. Okay, this is cart C, and this is shown in figure. The coefficient of friction between them is mu. Okay, so the acceleration. So the cart is moving with acceleration alpha. So find out for what acceleration alpha the block will miss. It will not fall down. Okay, so are you clear? Like, is it clear to you? Question. Your voice is not clear. If possible, please type. Have you understood the question? Hello. Please, if possible, please type because I'm not able to hear.
Hello, sir.
Hello. Now, please. Hello.
Yes, sir. I can hear you, sir. Can you hear me?
Yeah, I can hear you. Now I can hear you. So have you understood the question? Mm,
Yes, sir. I have understood the question.
Oh, okay. Can you try to solve it? Just take 1 or 2
Yes,
minutes
sir.
or
I
try to.
just said, sir, that my answer is like B.
Option B.
Yes, sir. Option B.
Okay, okay, 1 second, then I will try to solve it. So this is cart, okay, C, which is moving with acceleration alpha, and this is a mass m. So we have to find out basically the relation, or like basically we have to find out acceleration alpha for which this mass will not fall down. So if m is the mass of this object, then weight of the object is mg, which is acting downwards. So if it what we want is we want to prevent it from falling. So if we want to prevent it from falling, the frictional force Fr should be basically, or not Fr, but limiting frictional force. Okay, so limiting frictional force Fl should be greater than or equal to mg. So even if it is equal to mg, it will not fall. So it should be greater than or equal to mg. Okay, now mm, so now if you consider this diagram, this cart C is there, mass m is there, and both are moving with acceleration alpha. So if you see apply pseudo force on this mass, so it will be equal to m alpha, and it will act in opposite direction of its motion. So the normal reaction between these two objects will be equal to m alpha. So if normal reaction is m alpha, limiting frictional force Fl is basically mu into n. So it will become mu m alpha. Okay. So limiting frictional force is mu m alpha. It should be greater than mg. So mu m alpha should be greater than or equal to mg. M will get cancelled. So basically alpha should be greater than equal to g upon mu.
Okay. Okay, sir. Got it. Understood.
Okay. Okay. Fine. Okay, we have one more question. On horizontal surface of a truck, on horizontal surface of a truck, a block of mass 1 kg is placed and coefficient of friction is given as 0.6. So, and truck is moving with acceleration 5 meter per second square. So then the frictional force on the block will be, okay. So options are A is 5 Newton, B is 6 Newton, C is 7 Newton, and D is 8 Newton. Okay. So there is a truck. Okay. So let's say there is a truck which is moving and there is a block of 1 kg is placed over the truck, and this truck is moving with acceleration 5 meter per second square. Okay. So now you have to find out basically the frictional force acting on this block. So please take 1 or 2 minutes and try to solve this. Have you understood the question?
Yes, sir.
Okay, so please try to solve this.
Sir, I got 5 Newton.
Okay, so if you see this, let's say this is the 1 kg mass we have. So since truck is moving, this of course this object is also moving with, let's say, acceleration 5 meter per second square. So if we apply pseudo force, it will become 5 MA. So it will become 5 Newton pseudo force is acting in left direction. Okay. So here normal reaction is basically equal to mg, so it will be equal to m into g is 10 Newton. And if you see the limiting frictional force fl, it is mu n, so it will be 6 Newton. So in this case limiting frictional force is more than the pseudo force or force acting on this object, and therefore the frictional force acting on this object is will be equal to the force acting on this object, which is equal to 5 Newton. So it is correct answer.
Okay, sir.
Yeah. You got it by same method, right? Pi Newton.
Yes, sir. Pi Newton.
Yeah. So similarly, let's say we have a wedge again. Okay. This angle is, let's say, theta, and there is a block of mass m kg. So if this entire wedge is moving with acceleration a, so in this case, what will be the uh, normal reaction? And limiting frictional force. So mu is the coefficient of friction and g is acceleration due to gravity. Is it possible for you to solve this? Try to solve this.
Sir, the inclined block is actually moving with acceleration A.
Yeah.
Can you explain me this, sir? I don't know. I have no idea.
Oh, okay. So here this object is moving with acceleration a. Okay. So now if you draw the free body diagram of this mass, first let's apply the pseudo force. Okay. So if you apply the concept of pseudo force on this object, let's say, so this is the mass. So this system is moving with acceleration a. Okay. So if you apply pseudo force, it will become ma. Pseudo force that will be applied is ma. Okay. Now this angle is given as theta. So if this angle is theta, the other angle is also theta. You should, I think you must be knowing that. Then this angle is also theta, and mg is the weight acting in this direction. Mg cos theta is component along normal, and mg sin theta will be component in this direction parallel to this motion. And if you find out the component of ma, like pseudo force, then it will be one component. If this angle is theta, so component along this direction is basically ma cos theta, and its component along this vertical direction will be ma sin theta. So normal reaction is acting in this direction, and so n plus ma sin theta is equal to mg cos theta. So normal reaction here is basically mg cos theta minus ma sin theta. So frictional and limiting frictional force will become mu into n. So limiting frictional force will be mu into mg cos theta minus ma sin theta. You understood this?
Mhm. Yes, sir. I understood this one.
Okay. Similarly, okay.
Sir, one more doubt. If the
Okay.
inclined plane is moving forward with acceleration A,
Yeah.
then the block which is on the inclined plane, will it tend to fall down? And
So
in the previous case where we have seen in block problems.
so that will everything will depend on the what frictional force. Okay, we'll see that, like coefficient of friction and all. So now
Okay, sir.
other case, now you try to solve this, okay? Again, we have to find out normal reaction and the limiting frictional force. So again, this is mkg. G is acceleration due to gravity, mu is coefficient of friction, and in this time the inclined plane is moving in this direction with acceleration a. This angle is theta. So can you find out normal reaction and limiting force in this case? Just try to give attempt. You know the concept of pseudo force, so you will have to apply that.
Okay, sir.
Yeah.
Sir, uh,
Yes.
normal reaction is equal to mg cos theta plus ma cos theta, and limiting friction is equal to mu into that ma mg cos theta plus ma sin theta, ma cos theta.
May cost. Okay. So one more time I'll just try to tell. So you are here, if you see this as m. So if acceleration is in this direction, pseudo force of ma will act in this direction, okay? So if you pseudo force m is acting in this direction, this angle is, let's say, theta, and weight is acting in this direction, mg. So component of weight in normal direction is, this angle is theta, so it is mg cos theta. Similarly, if you resolve this, uh, see, this angle is theta, okay? This angle is theta. So now if you resolve, uh, so this angle is now theta, and this angle is 90 minus theta. So this component will become ma cos theta. This component will become ma sin theta. This component. So normal reaction will be mg cos theta plus ma sin theta.
Okay, okay, sir. I just mistaken by the comment.
Yeah, that theta. See the if see if this is the force, let's say F, okay, then, and this is its component at angle theta. So this component will always be F cos theta, okay. So
Okay, sir.
yeah, means the component which is along the theta is always F cos theta, and which is away from this theta is sin theta, okay. That you should always remember.
Okay, sir. Understood.
Okay. Okay, I'll just give you two example from both above concept only, okay. It won't be that difficult. I think within 1 minute you should able to solve this. So first one is, let's say this angle is 45. There is a mass of 30 kg. Coefficient of friction is 0.4. Acceleration due to gravity is 10 meter per second square. And this wedge is moving at 5 meter per second square in rightward direction. Okay. So here you will have to find out normal reaction and limiting frictional force. Similarly,
Okay, sir.
similarly, there is one more example. So here the angle given is 53 degree. The mass of this object is 40 kg, and coefficient of friction is 0.5. So and g is of course 10 meter per second square, and here the wedge is moving at acceleration of 10 meter per second square in left direction. So here also you will have to find out normal reaction and FL. Try to
Okay, sir.
solve it as fast as possible.
Yes, sir. Sir, for the first case,
Yes.
n is equal to 150 and limiting friction is equal to 60.
For 45-degree angle, is it 150? Can you try to calculate it once again?
Yes, sir. Yeah.
See, 45 is there means both cos theta, sin theta will have some root 2 component, right? Just can you
Uh, yes, sir. Actually, root 2 is there. I'm not taking root 2, sir.
so you are just getting 150?
1 minute, sir. Just I will calculate both the cases and I'll tell you the final answer.
Okay, okay.
Sir, first case I found, sir. Second case I'm facing a little bit difficulty about the angle. First case I will say, sir, answer. As normal reaction I got 106, 106 or approximate 106, and limiting friction I've got 40, approximate somewhere around 40.
Okay, means it is like 150 by root 2, right?
Sorry, sir.
Yeah, it is 150 by root 2 basically. You can write in terms of root 2.
Yes, sir. Actually, 150 by root 2. Approximately, I will get around 106, somewhere around 106, sir.
And other is 60 by root 2, right? Yeah, it is 40.
Yes, sir. Yes, sir.
Yeah, so in first case you got it correct. So in second case also angle is 53 degrees. So 53 degree you must be knowing, like if you have right angle triangle of 53, 37 and 90, then this is basically 5, 3 and 4 triangle. This you should always remember this triangle, okay? So if you remember this triangle, then like if you have some component, now it is 40 kg. Okay.
No, no, sir. This one, I did not face difficulty in the finding the angles. I found the angle, but somewhere around calculation mistake I'm doing, sir. That's what.
Okay. Okay. So now let's say you got the angle. So this is 40 kg. Okay. It is moving in left direction with acceleration 10 and mu is zero point 0.5. So force MA will act in this direction. So M is 40, A is 10. So 400 Newton will act in this direction. This is 53 degree. So this angle is also 53 degree, and this angle is also 53 degree. Okay. So So the force which is acting, normal force that will act, it will be 400 sine 53. Okay, means this uh, MA component of MA in vertical direction is basically 400 sine 53. So it is equal to basically 0.8 into 320 Newton. Okay, and there is mg is acting in downward direction, which is 400 Newton. So mg cos theta will act. So mg cos theta is mg cos 53, which is zero point 0.6. Cos 53 is zero point 0.6. So zero point 0.6 into mg. So it is 4 into 240 Newton will act like this. So normal reaction will be 320 plus 240. It will be 560 Newton. And FL will be equal to mu into N. So mu is given as zero point 0.5. So therefore, if mu is zero point 0.5, so FL will be equal to 280 Newton. 0.5 into 560. You got this or still have
Yes, sir.
confusion?
I got it. Yes.
Okay. That lift concept you have understood, right? Like when we are moving up in lift, normal reaction will be, what will be the normal reaction?
Yes, sir.
You got this last time, right?
Yes, sir. Lift concept.
Okay. Okay, fine. So we'll just see two small concept and we'll stop for today. Mm. So first one is angle of friction. Okay. Angle of friction. So let's say you have object and it is having mass, let's say some mass mkg, and you are, means it is having coefficient of friction between this object and surface, let's say it is mu. So there is normal reaction acting in upward direction, which is equal to mg, and you have applied a force which is just equal to limiting frictional force, let's say F. So therefore friction acting on this object, it is equal to mu mg. It is equal to limiting friction, which is mu mg. Is it clear till this point?
Yes, sir. Clear.
Okay. So there is contact force or reaction force. So it is basically the resultant of this normal reaction N and limiting friction FL. So contact force is basically the this is the contact force. It is resultant of these two forces, and the angle which it makes with the normal reaction is known as lambda, and it is known as angle of friction. Okay, so now you have two forces. One is limiting friction Fl, one is normal reaction N. So this resultant of these two is known as contact force or reaction force, let's say R, and the angle it make with normal is basically known as angle of friction. Okay.
Yes, sir.
Okay, so if you see this angle of friction in this right angle triangle, then if you uh, let's say mm, let's say if you find out first this resultant, okay, R. So this resultant R will be basically given as FL plus vector force FL plus N. Okay, and it's let's if you find out tan lambda, which is angle of friction, lambda is angle of friction, so it will be FL upon N, and FL is basically mu into N, and here we have N, so it will become mu. So tan of angle of friction lambda is basically mu. Okay, or you can say angle of friction lambda is tan inverse of mu. Okay,
Yes, sir.
yeah, and there is one more angle that is known as angle of repose. So let's say now you have a ground, okay, and this object, so of course on ground it will not move unless you apply some force. Okay, let's say it is having mass mkg, it is on ground. Now if you increase the angle, let's say to theta 1, but since there is, let's say mu is coefficient of friction between them, since there is friction, unless we know that unless this component of weight uh, is more than the limiting friction, this object will not move. So like that you went on increasing this angle, and finally you reach an angle, let's say theta. Okay, and mu is coefficient of friction. So if you increase the inclination or angle more than theta, then this block will start moving. So angle of repose is basically angle of inclination when block starts to slip. Okay, angle of repose is basically angle of inclination when block starts to slip. You understood its definition?
No, sir. Actually, no.
Okay, so see, this block is on ground and coefficient of friction is mu. So unless you apply any force, it will not move, right? It will remain as it is. Is it like clear till now?
Yes, sir.
Okay. So now if now you have given some angle theta or to this wedge. So if you have given angle theta, let's say mg mass was m. So mg is component of force acting downward. Then mg cos theta will be its weight acting in normal direction. So normal will be mg cos theta. Is it clear till this point? Mg cos theta 1.
Yes, sir.
See, we have considered theta as theta 1. Okay. Is it clear?
Yes, sir.
So limiting frictional force in this case will be mu mg cos theta 1.
Correct,
Okay.
sir.
So now there is like normal component of this weight is mg cos theta 1, and component along this direction of wedge is mg sin theta 1, right?
Yes, sir.
Okay, so unless this mg sin theta 1 is more than this limiting frictional force mu mg cos theta 1, this object will not move, right?
Yes, sir.
Means it will not, because it is not able to overcome the frictional force, so it will not move. But as you keep on increasing this, so here it is sin theta 1. So if you start increasing theta from 0 towards 90, sine theta will increase, and here it is frictional force is having cos theta 1. So if you go from 0 to 90, cos theta will decrease. Is it clear? Miss,
Yes, sir.
miss, you know that sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, and sine 90 is 1. Similarly, if you take cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, and cos 90 is 0. So if you go from 0 to 90, sine of angle is increasing. If you go from 0 to 90, cos of angle is decreasing. So if you start increasing this theta 1 here, let's say, this mg sin theta will start increasing, and this FL, that is frictional force, will start decreasing, right?
Yes, sir.
Okay. So then you will reach certain value of theta where this mg sin theta will be equal to mu mg cos theta, correct?
Yes, sir.
Okay. So, and if you still increase the theta, then this block M will start moving downwards, because then mg sin theta will be more than mu mg cos theta. Okay.
Okay, sir.
So basically, theta is the point where the mg sin theta, that is the component of weight along this direction of wedge, is matching with the limiting frictional value. So this is the point of repose. So if you, or angle, it is basically known as angle of repose. If you increase the angle more than theta, then this object will start moving downwards. But till you increase the angle till theta, this object will not move. It will be like, it it won't be moving. So this angle theta is known as angle of repose. You got it?
Yes, sir. Got it.
Okay, so now mg will get cancelled with mg. So you will get basically tan theta is equal to mu. Okay, so theta
Okay,
is
got it.
basically tan inverse of mu. So this is the angle of repose, theta. Okay,
Yes, sir. Got it.
okay. We'll take one example. So if let's say coefficient of friction is given as 0.75. So at what angle the block will start to slide? So let's say you have one block of m kg. This angle is theta. So at what angle theta this object will start moving? So we have seen that tan theta is basically mu. Okay. So they have asked at what angle theta this object will start sliding. So this is basically angle of repose. This is definition of angle of repose. So we have to find out that. So one method is directly put tan theta equal to mu. So theta is tan inverse of mu. So theta is basically tan inverse of 0.75, and 0.75 is basically tan inverse of 3 upon 4 is 0.75. So tan theta is opposite upon hypotenuse. So you have opposite side 3, and adjacent is, sorry, tan is opposite upon adjacent. So opposite 3, adjacent 4. So this hypotenuse is 5. So this is basically 37-degree angle. Okay. So for theta is equal to 37 degree in this case. And other method to find out this is, you know that this is the mass, and there is a component of weight acting in this direction, that is mg sin theta. Then normal reaction is mg cos theta. So normal reaction is mg cos theta. So limiting frictional force is mu mg cos theta. So you know that when it will start moving downwards, that means mg sin theta is almost equal to mu mg cos theta. So if you equate them, mg sin theta equal to mu mg cos theta, then mg will get cancelled. You will reach to that mu is equal to tan theta. So theta is equal to tan inverse of mu. So again, you can find out it is equal to 37 degree.
Okay, sir.